Hey guys, welcome to Functional Print Friday. If you like design and using 3D printing to solve real world problems and not just printing trinkets, this channel's for you. So this year my wife has upped her Christmas decorating game a bit by collecting these little handmade and hand-painted sort of Christmas houses. I think these are made in Germany, and I believe the name of the company that manufactures these is Hubrig. I don't read German, so I'm not 100% certain. If you are from Germany or have more experience with these, feel free to comment with some extra information down below. So these little guys, I think from the marking here, are designed to run at between 5.5 and 3.5 volts. I thought, since I don't completely understand what this is trying to tell me, that 3.5 volts was probably the safer figure to run these at. And they've got a unique plug on the end. I don't think this is standard. I couldn't find anything else that uses the same type of plug. It looks like little chrome steel pins. They are perfectly round, and they have, I don't know if this is going to show up on camera or not, they have like little slits cut in them so that the ends can pinch in as you plug into something. So we can't plug these guys into a wall outlet. That's not only is that not direct current, it's AC, which bulb isn't going to care if it's AC or DC, but that's way too much voltage. This thing's going to be really bright for probably like 2 milliseconds and then it's dead. So they do sell, this company Hubrig does sell an adapter that lets you plug one of these into a 5-volt supply and then into the wall and into an adapter, or into an adapter and into the wall, since our plugs are different here in North America. And they also sell a little power strip that I think it has maybe 6 or 8 outlets on it, not sure. But it still has the wrong type of connector on it. You're going to need to then get the adapter to go into a North American outlet. And the whole thing was, I don't know, like maybe 80 bucks for the strip as well as the adapter, and gave you, like I said, I think it was 6 or 8 outlets. My wife's already got 2 of these. I think she's got quite a few more on the way, and wanted a way to be able to light these up. We could just buy the solution that they sell, import it, and then go with the adapter route and everything, but it's a little clunky, and I thought I could do better. So what I came up with was this guy here. I essentially designed a power strip that delivers 3.5 volts that these guys can plug into. And top's a little custom here. I put the name of what I believe is the name of the company that makes these houses, and the 3.5 volts, so I don't forget in the future. And this has 14 outlets. So I told her she could only buy 14 of these, but she's going to get as many as she wants. So I foresee probably building another one of these in the future. But let's dig into this a bit. Well, first let's try it. So on this end we have just a standard wall wart. This is a 12-volt wall wart. There's nothing special about this. I've got a whole box of these things. Whenever we have any device that's sort of outlived its useful life, I always save the power adapter part. These are great for reusing. So let's plug this guy in, and you'll notice we have an LED light kind of comes on there, so we can see we've got power. And if I plug these guys in, they light up. These houses are really pretty cool. They're a lot nicer than the plasticky ones that she had before. So let's figure out how this thing works. Unplug it. And we'll slide these out of the way a little bit. And I designed this so that the cover of this actually slides off. It's just a friction fit. And if you remember, I mentioned that the power adapter is actually putting out 12 volts. I've got a buck converter in here. This is an LM2596. These things are super cheap and really, really great. I think, yeah, so 8 of these guys on Amazon is less than 12 bucks shipped. I'll put a link in the description of the video down below on the show more if you want to pick some of these up. For delivering a lower voltage like this, for this application or for anything really, you just need to, on the input side, you need to deliver more voltage than you want coming out of the output side, and on the output side, the voltage is controlled by this little tiny screw here. So I'm putting 12 in on this end, and I just tweaked the screw till I got the 3.5 volts that I wanted on this end. And it is a constant voltage supply. So as long as we stay within the amperage rating of this guy, it's still gonna just keep delivering exactly that 3.5 volts. So it is a bit tricky to see inside here. it's going to be easier to get a look at how this thing works when we take a look at the design files, but it's pretty simple. So it's deeper on this side where that LM2596 module sits. Again, the wires are soldered onto the input side, and then on the output side, short wires just come up here to these solid copper bus bars. And the way that I have the accurate placement of the holes is I actually used the design itself as a jig. I printed a second one of these top pieces, put the bus bars in place, slid this guy on, and then used this as a drill guide so that I got the holes exactly where I needed. And I drilled these holes to basically just a little bit tighter than the actual diameter of these steel pins, because remember they're slit on the ends, so they kind of pinch as you push them in. And the distance of the holes down from the top is such that the entire part of the chromed pin where it's slit goes into the copper, but the solid part stays up in either the air gap above that copper bus bar or in the thickness of the plastic up here. So it plugs in and out very easily. Also printed, I think, 3 different versions of this till I had the exact friction fit that I wanted. So this guy stayed in place but could be removed if I need to service it in the future. The way that we see that LED light is there's actually a tiny little surface mount LED on the board, that LM2596 board. And what I did is I just added another hole in my design for this sliding top piece, and I made it exactly 1.75 millimeters, the same diameter as standard filament. And then I just cut a tiny piece of, well, actually I cut like an inch long piece of clear filament, shoved it in there, and then trimmed it with a pair of flush cut snips on the back so that it is just the length is just enough to go through the cover. And it kind of acts as a light pipe so that we get the light coming in from that surface mount LED down here on the board. So, all right, let's go take a look at the design files for this. Okay, so here's the 3D design for this, and let's go ahead and get the lid off of this so we can see things a little bit better. And first thing I'll point out is, as mentioned before, you can see this is designed that it's keyed and slides into this bottom part, and then the other end acts as a stop. And at least on my setup here, this is a nice tight friction fit. It doesn't slide by itself, but you are able to, kind of grasp it tightly and push with your thumbs and get this guy to slide off to access the components inside. This side is just full depth, and it supports the height of that LM2596 module. This is the hole where the wires come in from that wall wart, feed the input side, and then on this side, our bus bars extend just past this side for us to solder those leads onto for the output of that unit. And let's get these guys moved out of the way as well so you can see, or we'll just move one side. You can see this is designed, that copper bus bar sits against this face here and against this face here, and then has room underneath of it. So as we drill those holes, the pins actually goes just slightly through that copper bus bar. I actually modeled the copper bus bars as well. This is based on a piece of copper that I already had existing in my shop. Here we can measure the distance. This is 2.5 millimeters thick. That was the thickness of the copper sheet that I had. You could probably go a little thinner and adjust the design, but 2.5 millimeters does work really well. And to cut these copper bus bars, I just printed, this piece out actually in plastic, and then traced this shape onto the copper sheet and cut the rough shape on my bandsaw, and then cleaned it up on a belt sander. And then again, they were drilled by actually placing them into this lower portion, and I 3D printed an extra of one of these top pieces and used it as a drill guide to actually get the holes into it. So that's it. Pretty simple, pretty straightforward. I'm very happy with this design. It works very well. And here's that hole also that I talked about that is exactly 1.75 millimeters. That lets me just slide a piece of clear filament in there to pass the light up through from the LED on the LM2596. So as always, guys, thanks for watching. If you enjoyed this, please hit the like button. Please hit the subscribe button. I put out new videos every single Friday. And it is always, either my design or design that of someone else's that I might focus on, that is to solve a specific real-world problem, and just kind of showing you, how it's actually working for me. As always, guys, thanks for watching. Take care.